In preview activity 1.4, we're given the function f of x equals 4x minus x squared, and we're asked to use the limit definition to find a few values. We'll do this for a couple, and we'll see that there's a pattern going on. So f prime of 0 is going to be the limit as h goes to 0 of f of 0 plus h minus f of 0 all over h. There's our definition of the derivative. And now we're going to apply that to our function. Limit as h goes to 0. And now f of 0 plus h means we're putting 0 plus h in for both x's. So we've had some practice at this, but it never hurts to get a little more. Minus 0 plus h squared. So that's just f of 0 plus h. We still need f of 0. Minus f of 0 is 0, so minus 0 all over h. So we're going to have limit as h goes to 0. 0 plus h is just h, so this will be 4h minus h squared all over h. As we've done in the past, and as we've seen before, that h, we can factor an h out on top and cancel. We're going to get the limit as h goes to 0 of 4 minus h, or the derivative at 0 is 4. Let's do f prime of 1. Limit as h goes to 0 of f of 1 plus h minus f of 1 all over h equals, now we're going to plug 1 in instead of 0. So this line is going to look almost exactly like the line up here, except the zeros are going to be replaced with 1s. So 4 of 1 plus h, 4 times 1 plus h, excuse me, and then 1 plus h squared. So right there, that part is the f of 1 plus h. F of 1, we're going to plug 1 into our function. We're going to get 4 minus 1, so minus 3 all over h. So we have the limit as h goes to 0, and now we can multiply this out. So inside these large parentheses, we're going to have 4 distributing this plus 4h minus, now this needs to be FOILed. It's not 1 squared plus h squared. It's going to be 1 plus 2h plus h squared. And then we'll have this minus 3 at the end, all over h. So we get the limit as h goes to 0. Now this negative will need to be distributed to each of these terms. So we have 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. And now we're going to start to see some things cancel out for us. For instance, 4 minus 1 minus 3. So 4, and that's a negative 4, those will cancel. And let's see what we have left. Limit as h goes to 0. 4h minus 2h is going to leave us with a 2h, so that takes care of those. Minus h squared over h. And now we're going to be able to cancel an h out of the top. Now remember, it has to be canceled out of each of them. That's why in the past we've been factoring them out. Here I'm just going to go ahead and cancel, and that's going to give me a 2 minus h, and that equals 2. So, for time's sake, I'm not going to keep recalculating. The work's the same regardless of which one you're doing. So f prime of 2 comes out to be 0. F prime of 3 comes out to be negative 2. And you might start to notice a pattern. Every time our input's going up by 1, our derivative is going down by 2. So we could extrapolate this and say, well, then f prime of 4 is going to be negative 4, and f prime of 5 is going to be negative 6. We can take this a step further and come up with a formula for the derivative. In general, just call it f prime of a. We can actually make this a function that takes in any value in any input and gives the derivative at that point as an output. what we see is we're decreasing by 2 each time, and we had a and it has a y-intercept of 4. So at 0 it needs to be 4. So it's a linear function with a y-intercept of 4 and a slope of -2. And there's a formula that will calculate the derivative at any given point rather than having to go through this process each time.